This is a general explanation of pH and pOH by Kaylin Gross. The definitions. pH is usually used to measure the concentration of hydrogen atoms in a substance, and pOH is used to measure the concentration of hydroxide ions in a substance. So they're basically the same thing, except they're measuring different atoms: pH, hydrogen, pOH, hydroxide. The pH scale. It measures the acidity or the alkalinity of a solution, and that's whether it's an acid or a base, and how much of an acid it is or how much of a base it is. And this scale is from 0 to 14. 0 makes it the most acidic, and 14 makes it the most basic. And you can find out what a solution is on a scale by using litmus paper. Water is 7 on this pH scale. Also, the 0 to 14 scale is considered a quantitative measurement, and then litmus paper, which you use, is terms red and blue, whether it's acidic or it's basic, is a qualitative universal indicator. Calculations. In order to find pH, you take the negative logarithm of the hydrogen ion concentration, which you would just plug into your calculator, type in negative log, and then your hydrogen ion concentration. And it's negative because the more hydrogen ions you have, the lower your pH is. So it's a opposite correlation. And you can find the pOH by taking the negative log of the hydroxide ion concentration. So it's basically the same thing, except you have hydroxide and pOH and hydrogen and pH. This is your calculation square, which is your conversions between pH and pOH and hydroxide and hydrogen. And pH plus pOH is always 14. So if you're converting in between the two, then you're going to have to take 14 minus your pH to get your pOH, or 14 minus your pOH to get your pH. And then we already told you about the negative log for pH and pOH conversions. So, yeah. Some important things. pH and pOH are only used when they're applied in aqueous solutions, which means that they're water-based. And that's because when water dissociates, it has a hydrogen and a hydroxide ion. So that makes it able to calculate the pH and the pOH. And that's it.
This is the pH and hydrogen conversions. So this is our conversion table that we're going to be using most of the time, and of course it's easy to see that it's easiest to go between pH and pOH because they always equal 7. So if your pH is 6, your pOH will be 8, and something along those lines. And of course you can go back and forth in between them, but you have to make sure that you use multi-steps if you're going from like pH to hydroxide concentration or something along those lines. So our first example, if your pH is 5.8, which would make it slightly acidic, what is its hydrogen concentration? So you take, that's going to be equal to 10 raised to the negative pH. So all you do is you take 10 and you raise it to the negative 5.8. And you plug that into your calculator and you get that your hydrogen concentration is 1.58 to the negative 6. Okay? And then if you have a hydrogen concentration of 7.2 raised to the negative 7th, what is its pH? So what you do there is you take the negative log of 7.2 to the negative 7th, and you just plug that into your calculator, and then you get that your pH is about 6.14. And that would also make it slightly acidic. Okay, so this is dealing with the self-ionization of water, and this is important when you're going in between the hydroxide concentration and the hydrogen concentration. And it occurs when two water molecules form a hydroxide ion and a hydronium ion. And the concentration of the hydronium and the hydroxide are equal because of the equal stoichiometric ratio. And a lot of times the hydronium can be used interchangeably with the hydrogen, so don't let that confuse you. So it is necessary to use the ionization constant of water for the conversions, and that's just 1 times 10 to the negative 14. So let's do an example of that. A solution has a hydrogen ion concentration of 1.2 to the negative 8 molarity. What is the hydroxide ion concentration? So all you do there is you take 1 times 10 to the negative 14th and you divide that by your molarity of 1.2 to the negative 8. And you plug that into your calculator and you get that your hydroxide ion concentration is about 8.33 raised to the negative 7. And that's it.
Alright, so in this experiment we will be testing the pH levels using litmus paper and a universal indicator. First we'll start out by testing the litmus paper that has a pH scale shown on the front. The solutions we will be using are vinegar, water, and sodium hydroxide. We'll start out by testing the litmus paper on the vinegar solution. As you can see, the vinegar has caused the litmus paper to turn an orange color. The water has caused the litmus paper to turn a green color, and sodium hydroxide has caused it to turn a dark blue color. Next we'll take the universal indicator and add about a drop into each solution. To determine the pH level of each solution, we can look at the chart shown on the right. As you can see, vinegar has a pH level that is between 2 and 3. Water has a pH level that is about 7, and sodium hydroxide has a pH level that is about 14. Looking at the pH scale, you can see that the numbers on the spectrum only go from 1 to 14. The numbers that go from 1 to 7 are more acidic because they have increasing hydrogen ions, while the numbers 7 through 14 are more basic because they have increasing hydroxide ions. Out of the 3 solutions in this experiment, we can determine that vinegar is an acid, water is neutral, and sodium hydroxide is a base.
Calculating pH by Precious Tudose. Okay, this is the pH chart we'll be using to solve the problem, and we'll be using pH to POH and OH to POH. The different ways for solving pH that we'll be using is POH equals negative log OH, OH equals 10 to the negative POH, and POH plus pH equals 14, and that's only used for aqueous solutions. Example 1. Find the OH given the pH or POH if you're given the pH of 6. So for this problem, you would have to use pH plus POH equals 14, and you would have to subtract 6 from 14, which gives you the POH of 8. Then you plug in your POH into your OH equation, and you'd get OH equals 10 to the negative 8, and when you plug this into your calculator, you get OH equals 1.0 times 10 to the negative 8. Example 2. Find the OH given the pH or POH if you are given a pH is 5.5. So you plug your number into your equation and you get POH plus 5.5 equals 14, and you subtract the 5.5 from your 14 and get a POH of 8.5. Then you plug this number back into your equation and get your OH equals 10 to the negative 8.5, and your final answer is 3.16 times 10 to the negative 9. Example 3. What is the pOH of a solution that has a hydroxide ion concentration of 4.82 times 10 to the negative 5 molarity? For this problem, the equation you would use is pOH equals negative log times OH negative OH. And your pOH equals negative log, and you plug your number given in the equation into the given equation, and you get a pOH of 4.32. For example 4, what is the pOH of a solution whose OH is 9.31 times 10 to the negative 2 molarity? And you would be using the same equation and plug your number into this equation and get a pOH of 1.13. Example 5. What is the pOH of a solution whose H ion is 2.75 times 10 to the negative 4 molarity? For this problem, you would use the equation OH equals 1 times 10 to the negative 14 divided by your hydrogen ion. So you plug your numbers into the problem and get OH equals 1 times 10 to the negative 14 divided by 2.75 times 10 to the negative 4, and you get an OH equals 10.44. Example number 6. Find the pOH if you're given that the pH is 7.8. So you'll be using the equation pOH plus pH equals 14, and you'd plug this into your problem and subtract the pH and get a pOH equals 14 minus 7.8 and get a pOH of 6.2.